Anyways, so here we're going to be talking about section 12.6. So we're going to skip over to binomial theorem. And so in order to do the binomial theorem or binomial expansion, right? So we start with Pascal's triangle. So you might have seen this triangle before in your life. Actually, let me know what happens. Have you guys seen this before? Where it's one, and then this is 1 and 1, and you add these two up, you get 2. We add these two up, we get 3. We add these two up, we get 3. We add these two up, we get 6. We add these two, so the 2 above it gives you 4. I want to say yes, but my brain says no. Fireworks in a trash can. Let it. So here 4 plus 6 is 10. And so this is just how I do this. So let's just write out the next 2 rows really quick. So do me a favor, try to figure out what the 7th row is. Write out the 7th row for me, and then I'll give you the 8th. Use a fire extinguisher to dump fireworks into a trash can. I am confusion. Fair enough. So in order, the way Pascal's triangles work is you just write out, you put a 1 here, and then you have, and the first 2 are actually given. So if there's nothing there, there's a theoretical 0. And in order to get this part, you're going to add 1 and 1. Here, I'll give you the first couple terms. So here, for the 7th term, my first term here is going to be a 1, right? Then I'm going to add up 1 and 6, I'm going to get 7. I'm going to add up 6 and 15, I'm going to get 21. Okay, and then keep doing that until you get the next row. Oh, someone already got it. Yep, so that's it. Okay, I got that too. Perfect. So here we're going to have 1. Here, I'll just write it down. Here, we'll have 1, 7, 21. These will give you 35. This will give you 35. This will give you 21 again. And notice once you get to the halfway point, you can just copy the numbers back. So here, if I do this, we 1. 1 plus 7 is 8. 7 plus 21 is 20, or is 28. This gives me 56. This gives me 70, and then it'll be 56 again. And then these two give me 28, or you can just, once the numbers, they'll mirror each other. And so this will be 8 and this will be 1. Okay. So let's actually show that this is useful. So we're going to expand a plus b to the n for n equals 1, 2, 3, and 4. Okay, so we're going to do this the long way for a second, and then we're going to see a pattern. All right, so here, a plus b to the first power is just a plus b. Pretty boring, right? A plus b to the second power is equal to a plus b times a plus b. Here we're going to FOIL, so we'll have a squared plus 2ab plus b squared. All right, a plus b raised to the third power is going to be a plus b squared times a plus b. And the reason I'm writing it this way, because I already know what a plus b squared is. So it'll be a squared plus 2ab plus b squared times a plus b. That's going to give me, let's just do a, so we'll have a cubed plus 2a squared b, that's a plus, sorry, plus ab squared plus, and then here we're going to do the b part, a squared b plus 2ab squared plus b cubed. And if I add this up, I'll get a cubed plus this and this will add, so I'll get 3a squared plus b plus this and this will add, I'll get 3ab squared plus b cubed. Okay. And then here we're going to do a to the fourth. So a plus b to the fourth is going to be equal to a plus b cubed times a plus b. So I'm just going to multiply this times a plus b, right? So if I multiply this by a, so this multiplied by the a is going to give me a to the fourth plus 3a cubed b plus 3a squared b squared plus ab cubed. And then I'm going to add to that the b, multiply this by b, so I'll get a cubed b plus 3a squared b squared plus 3ab cubed plus b to the fourth. Add that all together, and I'm going to get a to the fourth plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the fourth. This ramps up fast. Yeah. All right, so, but the reason that we want to go over this, let me just zoom out for a second. Notice here that my coefficients here are 1 and 1. My coefficients here are 1, 2, 1. My coefficients here are 1, 3, 3, 1. My coefficients here are 1, 4, 6, 4, 1. Does that look strangely familiar? Maybe, right? And so what happens is that in order to do this, yeah, wow, cool. And that's why I go through this process, is it actually shows you what happens here. Is that this Pascal triangle is just this expanding. And so what I do here is if I have 1, it'll be a to the first, and then this. And then notice here the powers of a go down. So I started a squared. So if this is 2, I started a squared. And then my next one has 1 less a and 1 more b. So the power of a went down by 1. The power of b went up by 1. So I went from b to the 0 to b to the 1. And then it goes down by 1, up by 1. Notice here it's a cubed. So here I'm cubed. And so this goes, the next one, a goes down by 1, b goes up by 1. Next one, a goes down by 1. So a squared. And then b goes up to 2. And then this goes down. Same for here. I started a to the fourth. A goes down 1. B goes up 1, A goes down 1, B goes up 1, A goes down 1, B goes up 1, and then A goes down to 0, and B goes up to the fourth. And so, with all that said and done, wow. General guidelines for this is so if I want to expand this, there are n plus 1 terms, with the first being a to the n, right? So a to the n, and the last being b to the n, all right? So those are my first and last terms. The exponent decreases on a from term to term as the x, so it goes down by 1 as b goes up by 1. And the exponents, every time I add them up, should add up to n. So if you're ever confused, like if you're at 7, it's like, well, did I miss something? Just add up the exponents and see how you're doing. And the coefficients is the nth row of the Pascal triangle. So given that, we should be able to expand all these, and we'll go through them. So here I have a plus b to the 7. So let's say it's a plus b to the 7. Well, we have our 7th row, right? I'm going to rewrite the 7th row on this paper so you can see it. Oops, there's not, this is 21, 35, 35, 21, 1. So that's our 7th row of the Pascal triangle. All right, so here, our first term is a to the n. So a here to the 7th. Right, with 1 is my coefficient. My second term will be 7. A will go down by 1, so this will be a to the 6th, b to the first, right? And then the next one will be 21, 21, a to the 5th, b to the 2nd. Notice if I add these two up, I get 7. The next one here would be 35. A is going to go down by 1, so a to the 4th, b will go up by 1, so b to the 3rd. We're going to do this one more time, so it'll be 35 again. A to the 4th. Oh, no, I'm going down. So A would be third and b to the fourth. Notice this still adds out to 7. Next one would be 21. A to the second, b to the fifth. The next one, I'll have to write it on the next line here. 7. A, b to the sixth. And the last term would be 1 times b to the 7. Okay? All right. Now, this isn't always A and B, right? We can have more interesting things here. So let me explain how this works. And so for the next one, we're still going to do this the same way. So let's just write down the fourth row. So the fourth row is 1, 4, 6, 4, 1, right? So that was our fourth row. All right, so now we're going to do this. So here I'll have 2x is my original term. So this would be 2x to the fourth plus 4, 2x, because 2x is now a, right? A equals 2x in this case, right? And b equals 3 to the fourth. So this is 4. So I'll have 4, 2x to the third, and then 3y to the first, plus 6, 2x to the second, 3y to the second, because remember now a is 2x and b is 3y, plus 4, and then we're going to bring down what the a was to the first power, 3y to the third power, and then the last one will be 3y to the fourth power, okay? But we're not really done here. We actually need to crunch through the numbers. So if we crunch this through, 2 to the fourth is 16, x to the fourth, plus 2 to the third would be 8, times 3 times 4 gives you 96, x cubed y. 2 squared is 4, times 9, times 6, which gives us 216, x squared, y squared, plus 8 times, oh, this is the same. This is the same, yeah, so it'd be 216 times x, y cubed, and then y to the fourth, or 3 to the fourth is 81, y to the fourth. Okay, and then all I'm doing here is just putting in these and crunching through what the coefficient is. That isn't too bad. All right, let's just do this real quick. All right, so our fifth one. So if this is our fourth, let's go ahead and write down our fifth. So fifth would be 10, 10, 5, 1. Yes, so here's our fifth. And so here we'll have this. And so notice what A is here. A is equal to 2. B is here is equal to actually minus 3x, right? Go ahead and make this a plus. And so notice here if I have A plus B, that's going to be equal to 2 minus 3x, right? So we've got to make it so B has to be negative in this case, okay? So if you have a negative symbol, or the minus, if you just go ahead and just suck that into B. And so we'll have this, and then we'll crunch through this. And so here, my first term here would be 2, which is my a to the fifth, plus 5, 2 to the fourth power, times minus 3x to the first power, plus 10, 2 to the third power, minus 3x to the second power. Notice this, these powers add up to 5. The next one would be 10. Just grab the coefficient from here. Drop down the coefficient, drop this coefficient down up 1, this one up 1. So it'll be 2, 2, minus 3 to the third. And then we'll have 5 times 10. Oops, no, 5, not 10, times 2 times minus 3x to the fourth, minus, and then plus the 1, minus 3x to the fifth. We just crunch through the numbers. 2 to the fifth is 32. plus, oops, hold on. Notice we'll have a minus to the first power, so negative 3 times 5 gives me negative 15 times 2 to the fourth, which is 16, so negative 240 x. Then the next one will be plus 10 times 2, so negative, I have 8 times negative, or positive 9. Remember, this is positive now because I squared it. So 72 times 10, which is 270. You don't need to do this in your head. Just, you could crunch this all through with the calculator if you like. And this would be x squared. So everyone see where I'm getting these? Here, just crunch this in a calculator. And you're going to get minus 108 x cubed. Crunch this one in a calculator. So 5 times 2 times, so 10 times 3 to the fourth, which is 81. So this is plus 80 times 10, so 81 times 10, x to the fourth, minus 243 times x to the fifth. Okay, yeah, everyone's okay with this. All right, so that's just how you expand these out. Let's talk about factorial. So in math, if I say like two with a big exclamation point on it, what I really want to do is just say that's 1 times 2. If I say 3 with a big exclamation point on it, that's really just 3 times 2 times 1, right? And so here, the exclamation point means factorial, means you multiply all the integers or all the natural numbers up to that number. And so you can only do factorial of natural numbers. Have you guys seen this before? The factorial? Yeah, yeah, most people have. Okay, so, and just real quick, we define 0 factorial to be 1. That's for a specific reason we won't get into. All right, so let n and r be non-negative integers, and where r is less than or equal to n, right? So here we're going to call, and so we can use this formula here, and we write it this way. This is combinations. We skipped the whole thing on statistics. We're just doing combination because you don't need stats for this. And so r over n is just n factorial divided by r factorial n minus r factorial, right? So this is combinations. Where this comes from, let me see if I can, yeah, this. Have you guys done combinations before? Yeah, where it's n, where it's, yeah, it's like, yeah, okay, well, you've seen it before, maybe. It's just basically if I have n objects and I choose r of them, what are the chances what's the chance I grabbed r of them? That's really what it means, right? And strangely enough, that these, let's see if I can find something. Yeah, that makes my brain hurt. Let me just type in combinations real quick. Not to get you too lost in the statistics, but just where it comes from. Combinations math. Yeah, there we go. Yeah, so here, we do, hold on. Yeah, so here, if order doesn't matter, we do combinations. If order does matter, it's called permutations, right? So here, if the order matters, we do this. If order doesn't matter, we do this, right? These are combinations. So, and here they're just talking about if you grabbed a pool ball, without order. And so the funny thing is let me see if I can actually see if I can find the combinations. Pascal triangle. So the funny thing is that these numbers here for Pascal's triangles is just the same as the combinations of 1 choose 1, 1 choose 0, 1 choose 1, 2 choose 0, choose 1, 2 choose 2, 3 choose 0, 3 choose 1, 2 choose 3. So it's actually these are the same, right? These are the exact same. And so all these, let's actually crunch through a couple just for kicks and giggles, right? So if we choose 5, choose 1, so 5 choose 1 would be the second thing in the row, right? Let's actually do 5 choose 2. That's a little bit more interesting. So 5 choose 2, I'll have 5 factorial up here divided by 2 factorial divided by 5 minus 2 factorial will be 3 factorial. So 5 factorial is 1 times 2 times 3 times 4 times 5. 2 factorial is 1. 1 times 2, 3 factorial is 1 times 2 times 2 times 3. Well, 1 times 2 times 3, I can just cancel all this out. I can cancel out a 2 here, and I'll get 2 times 5, which is 10. And if I go to my little triangle, back to my triangle, notice that 5 choose 2 is the third term. So 1, 2, 3, and there we go, right? We have our third term right here. And so that's 10. And so we can figure out what any of these things in Pascal's triangle is by doing this. And so let's do this. Let's find this one. So here we're going to have, I hate probability. Me too. All right, so here we're going to have 6 factorial over 3 factorial, and then 6 minus 3 factorial is 3 factorial. So what do we get here? We have 1 times 2 times 3 times 4 times 5 times 6, all over 1 times 2 times 3 times 1 times 2 times 3. To simplify this, we just cancel these out. 2 times 3 equals 6, and so I have 2 times 5, which is 20, right? And so 6 choose 3 should be the fourth entry, right? Or the fourth entry in Pascal's triangle. Same as okay, so if we come here, that should be the same as our fourth. Oops, right here. And our fourth entry indeed is 20. Okay. Oops, one more. All right, so let's just crunch through a couple more of these just real quick, and then I'll explain how to do these really large ones. All right, so here, we have 9 factorial over 4 factorial, and the other one would be 5 factorial. So this is going to be 1 times 2 times 3 times 4 times 6 times 7 times 8 times 9, all over. You can crunch this through a calculator, but I'm just showing you how to do it by hand. 1 times 2 times 3 times 4 times 1 times 2 times 3 times 4 times 5. You can always just take the larger number, cross off that, and then see what you can get rid of from here. So 2 and 3, that gives me the 6. The 4 and the 8, I can get rid of that, make it a 2. All right, so I have 5 times 2, which is 10. Oh, no, I got rid of the 5. Whoops, 5 is gone. So I have 7 times 2, which is 14 times 9. So it'll be 140 minus 14, so that'll be 126. All right, so what we got here? So let's just do this awful one. So this would be 100 factorial over 3 factorial over 97 factorial. So this is 1 times 2 times 97 times 98 times times 99 times 100 divided by 1 times 2 times 3 times 1 times 2 all the way up to 96 times 97. So notice that all these would cancel all those. So all these will cancel all those. And so I'll have 2 times 3. So 6 divided by 98 times 99 times 100. Just going to set through a calculator. We'll get 160. All right. So go ahead and, so I'm going to ask you guys to do D for me. Tell me what D is. And technically you should not need to pull out a calculator to do so, because something should be, once you write out the next step, it should be obvious what the answer is. So watch. Anyone write out the next step? What's just the next step before you crunch the numbers? What's that? Is this wrong? But I got, yeah, no, that's right. That's 100% right. So you get 100 factorial over 97 factorial over 3 factorial. Well, that's going to give you the same number we just achieved, right? These are the same. And so what I kind of wanted to hit at here is that n minus r and r are the same, right? So these are the same, right? So these are the same, and that's why in Pascal's, and we see that here in Pascal's triangle, right? If I choose 1 or I choose all but 1, it's the same number, right? If I choose 2 and if I choose all but 2, it's the same number. If I choose 3, that's a unique number, right? So here's the general term for binomial expansion. So let's just say I want to find the term that contains Rn, right? And I want to figure out what that term is, right? So here, I'm going to just use this formula, be n minus r, a to the r, b to the n minus r, okay? And so here we can calculate something ridiculously large, right? And so let's pretend I want to find this, right? So here, r equals 5 in this case, right? Because I wanted to find the AR term. So here I'll have, and then n in this case is 20. So if I want to find the term that contains this, of this expansion, I'm just going to say r equals 5 and n equals 20. We're going to crunch through this. And so when we do that, we're going to have 2x raised to the r power, so that's 5. We're going to have y raised to the power, which is not, so 5 minus 20 will give us 15. And then we're going to choose n, so n here is 20. We're going to choose n minus r, which is 5, so it'll be 15. Oops, that doesn't equal. And then we're just going to crunch this through. So this will be 20 factorial over 15 factorial over 5 factorial over 5 factorial times 2 times x to the 5th, y to the 4th, 15th. Notice here, do not do this by hand. Absolutely do not do this by hand, right? Just crunch this through a calculator. Type in 20 factorial over 15 factorial over 5 factorial times 2 to the x to the 5th times y to the 15th. Crunch that through, you're going to get this fun number here. Okay. All right. All right, so let's talk about if I wanted you to find very specific terms of an expansion. So here we have this expansion. A here is square root of x. B here is -1, right? Remember, we have to make this, right? Here, our n in this case is 8. So here, a is the square root of x, b is -1. So remember, if there's a minus sign, plug it into b. My n is 8, and I want to find the fourth term. So remember that the coefficients on the term go n equals 0, n equals 1, n equals 2, n equals 3, right? And so if I want to find the fourth term, I'm going to find, so the fourth term would be r equals 4 minus 1, which is equal to 3. So we're going to have r equals 3. For the seventh term, we're going to have r equals 7 minus 1, so I'll have that to be 6. And so here, in order to find the fourth term of the expansion, we're going to just calculate 8 divided by, so 8, 3, right? 8, 3 times a to the, so ax to the r, and r here would be, r here is, oh, oh. I'm doing something silly here. Because the fourth term r, I'm using a different r. Hold on, guys. R here is, I forgot your book to find it, weird. For the fourth term here, I'm going to have 8 minus 3 because I've gone down 3 here. So my r here, let me redefine my r, right? Let me redefine my r for you guys so I don't get you confused or lost. Hold on. Hold on. All right. Fourth, right? And so here's how these things go. So the coefficient for the a to the r term, so here they're defining this for the a to the r term. Let me not use r in this case, let me use q. Let me use q, right? And so if I want to find the qth term, let me put it up here. So the qth term, make that look like a q, right? The qth term is defined by n q minus 1, a to the n minus q, b to the q, okay? So if you want to find the term that contains a to the r, use this expression. If you want to find the qth term, I just need some letter here. So the fourth or the seventh term, notice here, we're going to take q minus 1 for this, and then it'd be, so yeah, this works out. This works great. This works great. So if I give you two formulas, that actually makes your life easier, right? If you want the term that contains this, use this term. If you want the qth term, use this, okay? So here, our q for the fourth will be q minus, oh yeah, perfect. I don't even have to do, oh, hold on. This be q, minus 1. I need to add another 1 here and a plus 1 here. Sorry. This makes it work out. Sorry, I'm making a formula on the fly. Yeah, because the first term would be n here, right? So it'd be q minus 1 plus 1 minus 1, and then q of, oops, that's also, hold on, let me make sure I do this right. 1. Yes. Okay. Sorry, making formulas on the fly. So Q for the fourth term is, so if you do this, you just type in literally 4. You don't actually have to think about anything. So here it'd be, here A is 8. Here we're going to type in 4 minus 1 times A, which is square root of x, times 8 minus 4 minus 1 times B times 4 minus 1. Oh, and B here is, we know what B is, it's negative 1 times 4 minus 1 minus 1. There we go. And then here we can simplify. This is 8 to the third, square root x to the fifth, and then minus 1 to the third. Yes. Okay, yeah, this is definitely the fourth term. Okay, so use this for, or oops, this should also have a minus 1 on it. And this should also have a minus 1 on it. Notice here this adds up to be 8, so I know I did the formula correctly. So here, and then we just crunch this through a calculator. So this becomes 8 factorial over 3 factorial over 5 factorial times the square root of x to the fifth times negative 1. So if I crunch through that, I actually get minus 56 x to the 5 halves. Okay. All right, let's go ahead and get rid of this. So I have room to do that. Now that I've crafted the new formula for you guys, let's do the seventh term. So for the seventh term, so this is the fourth. So for the seventh term, we're just going to plug it into the formula I made, right? So it'll be 8 of 7 minus 1 square root x to the 8 minus 7 minus 1 times negative 1 to the 7 minus 1, which gives us 8 to the 6, or 8 choose 6 of x to the second power, negative 1 to the sixth power, which gives us, and if we just crunch this through a calculator, you're going to get 28x, which is correct. Okay. I keep making factorials into fractions. Yeah, I keep making these into fractions too. It's easy to do. It's so easy to do because if you write a number over a number, your brain is just literally hardwired to draw a line. Okay? All right, so let's look at the homework real quick and then we'll let you guys go. All right. Yep, okay, so remember these and choose that. So I just constructed this. That is not, where's the homework? Did I lose the homework? I've lost the homework. Campus. Campus. All right, let's look at the homework real quick. Make sure you understand what you're asked to do. And then we'll let you go do it. And then I'll go finish writing all the stuff I need to and post the notes. All right, so here I have you expand x plus y to the sixth. So you just kind of crunch through this, write it all out. Here I have expand x squared plus y plus 1. So remember, this is your a, this will be your b to the fifth. Go ahead and just write that out. And then, oh, I asked you just whatever term it is. So what's the third term of this expansion? So use the new formula. Use new formula here, right, to get your answer. And the fourth term of this expansion. So use the new formula here, okay? Did I do something horribly wrong? Shouldn't it be plus 1? You might be right. Hold on. Let me, hold on. Let me see if I can't find the formula officially. Let me see if I can't find the formula officially. So I'm trying to make it up off the top of my head. The nth term in the nth term expansion of binomial. Thank you. Could I just have the formula, please? The book gives it the weird way. So the first term, the third term, we can generalize to a to the r n minus r times r. So the nth r plus 1 term is given by this, right? So I was just trying to write it as the rth term. So it'd be r, so minus, so yeah, this one would be plus, this would be plus 1, the other one's minus 1. Let's do this. Let's do this real quick. So this one is plus 1. This one is minus 1 if you want it for the qth term. Let me just open up another sheet real quick. Let me open up another sheet so I don't get anyone lost. New sheet, please. New sheet me. All right, so the way it works is the r plus 1 term is given by n to the r, a to the n minus r, b to the r. And I try to translate that for the nth term. And so here, it'd be n, or the r plus, or the rth term, r, make that look like an r. And I said r minus 1, it'd be a to the n minus r minus 1, which would be plus 1, over b to the r, which would be r minus 1. Yes. So these are the two formulas. Sorry about that. Your book only, the book, I got it from, wrote it the other way. So if you want to think about it, the n plus 1 term, so just minus the 1 away, that's what I was doing, because this is the formula I have in my head, not the one the book gave, right? You can do it this way. So just minus the 1. So if I was looking for the fourth term, my r is 3, and then I can crunch through this. It's just easier to do. And yeah, so let's just say, I guess I'd learn this one. I guess I would learn this one for the term n plus 1 term, or the r plus 1 term, right? Since we're using r plus 1 term. So you just choose n, choose r. So just minus 1 away from your r. So if I was on the fourth term, remake your r to be 3, and then use this formula, right? If I was on the seventh term, remake your r to be 6, and use this formula, okay? Does that make sense, guys? Sorry that's a little confusing. Does it make sense now what to do? Yes, no? Sort of. Yeah. So if you want, I hope so. Well, go do the homework. Go do the homework. And if you get lost, I guess you just use the formulas for now. Yeah, just use the formula. Use either this formula if you, so just minus 1, or you can just calculate it directly. And here I'm just plugging in 1 minus r, and I forgot the minus here. Okay.